Hey guys, it's Miss Emily again. Now we're going to go through interpreting graphs. So here's this first graph. It asks what interval is the function increasing? So it already tells us that it's a function. We can see that because it passes the vertical line test. But first it asks, where is it increasing? So remember, we read graphs from left to right. So starting from this top left corner right here, and then going all the way down to the bottom, I can see we have a minimum value. So right here, the y value is 8, and down here the y value is -4. So from 8 to -4, that's going down. And then I see after that, from y equals -4, it goes back up to y equals 8. So then that's going up. So I know that it's decreasing in that first half of the graph, and then it's increasing in that second half of the graph. Alright, but I'm going to talk about it in terms of x values. Typically when it asks interval of increasing and decreasing, it will talk about it in terms of your x values. And so this right here, this minimum value, is going to be critical to answer all of these questions, or most of them. So where is it increasing? After that point. So this is x equals -4. Right here, this is the x part. It's also y equals -4, but I'm looking at the x. So x equals -4. After that point, it will be increasing, and so my answer is going to be x greater than -4. You might see that it's worded between some x value and some other x value. In this case, this answer right here, x greater than -4, is going to be more accurate because I have an arrow showing me that it continues beyond what we can see. But just so you can get used to the wording, sometimes they'll say between x equals something and x equals something else. So x equals -4 and x equals, let's call it 0, because right here is where x equals 0, and then y equals, something a little bit greater than 8. But we don't have to be super specific because, again, this is just to get used to that wording. So between x is equal -4 and x equals 0, you might see it like that, although this is more accurate. Okay, so where is it decreasing? It's going to decrease before that minimum value. So kind of just the same idea as the increasing interval, but now it's wherever x is less than -4. So the accurate answer is less than -4. But again, I'll write it how you may see it written between. Now x equals -4 is going to be my second value that I talk about because we read the graph from left to right. So between x equals something and x equals -4, let's see what that something is. We can call it -7 if you want, because right here is where it corresponds to x equals about -7. Okay. So what is the minimum of the function? The minimum is where x equals -4, but I'm going to be even more specific than that and write it as a coordinate pair. So x is -4 at that point, and also y is -4. So -4, -4 would be that minimum value of this function. And then finally, what are the x-intercepts of the function? The x-intercepts happen where it crosses the x-axis. So that happens twice in this case. And that appears to be a -6 and a -2. those are the x values at those points. But we know that whenever it's an x-intercept, that's crossing the x-axis, and therefore the y value is 0. So the x-intercepts are -6, 0, and -2, 0. The second thing that you see in these coordinate points is always going to be 0 for x-intercepts, just like it's always going to be 0 in the first place for your y-intercepts. Okay, moving on. This next one looks pretty similar, but now it's facing down instead of facing up. So that tells me instead of a minimum, I'm going to have a maximum. And instead of decreasing first, it's going to be increasing first. But let's talk about it. Let's talk it through. So I know it's going to be critical to have that marked, and that is my maximum. And that is where x equals 0. And so whenever it's facing down like this, it's going to increase first, then decrease after that maximum value. We can see that just by reading this graph from left to right. And don't pay too much attention to the fact that the arrows are pointing down. That just is telling us that it continues beyond where we can see. But it doesn't let you know that it's decreasing right here. So don't be confused by that. It is actually increasing from here to here. So that would be from anything less than x equals 0. So if x is less than 0, it's increasing. And then after that point is where it's decreasing, so that would be x greater than 0. But if you wanted, again, to look at it from between some x value and some other x value, you could say, from x equals -2 to x equals 0. And then you could say from x equals 0 to x equals 2-ish is where now it's decreasing. But again, this is most accurate. What's the maximum? Well, we're halfway there. We said what the x value was for the maximum. So when x is 0 right here, then y looks like 2. So maximum is 0, 2. That also happens to be where it crosses the y-axis. So like I said, anytime you have 0 in that first spot and a y value, in the second spot, that's your y-intercept. And we can see that on the graph because that point right there is where it crosses the y-axis. And so your y-intercept is also 0, 2. Your y-intercept is your maximum in this case. That's not always the case. Now it's asking for y-intercepts, x-intercepts, we just did the y-intercept. The x-intercepts, there's 2 of them. That's where it crosses the x-axis. It's at this point right here and this point right here. So that would be -1, 0 and 1, 0. Cool. Hopefully that's clear where I got those from. Next, this one is not as smooth looking as the previous ones. So we have the intervals of increase and decrease are going to be a little bit more discrete. And so then it will be more accurate to do the between this value and that value type of thing instead of x greater than whatever, x less than whatever. So let's go through it and it'll make more sense. On what interval is this function increasing? So increasing, we're reading it from left to right, where is basically between which 2 points are the y values getting greater. And so I'm looking at these 2 points right here. Between those, the y values seem to be increasing. And so this line right here is where the function is increasing. Now I just need to describe it in terms of those x values. So at this dot down here at the bottom, x is equal to 0. And then this graph is going up by 1s, and so this right here is x equals 2. So where it says, where is the function increasing, you would say between x equals 0 and x equals 2, and that is actually the most accurate way to say that because we have discrete points and we don't have an arrow letting us know that the graph is continuing in this example. Okay, we're going to do the interval of decrease the exact same way. Now I'm looking at these 2 points right here. Because if I read it from left to right, it looks like those y values are getting smaller and smaller. And so that lets me know that the function is decreasing between these 2 points. I'm still going to use x as my way of determining intervals of increase and decrease. So right here, x is -5. This point's overlapping, so it's still x equals 0 for that. So the answer to where it's decreasing is now between x equals -5 and x equals 0. You're always going to write it from left to right as well. So -5 is less than 0, so that is going to come before. This comes before this in the sentence. All right. Y-intercept, same thing, where it intersects the y-axis, and so again, it's doing it at the minimum point, so that's not always the case, but in this example, it's crossing the y-axis at that minimum point. So x equals 0 right here. Whenever x equals 0, I know that that's my y-intercept. And so I got 0 is my x value, and my y value is -2 at that point. And like I said, that just happens to be our minimum. All right, cool. I do want to mention that this line over here, we didn't do anything with, but that's because it's neither increasing nor decreasing. It's stagnant between those 2 points. So it stays the same. So like if this was a position versus time graph, that right there would represent staying still. And this would represent, moving backwards, and this would represent moving forward, if it was position versus time. But basically, this is not changing between those 2 points. Your y value is not changing, so whatever your y represents is stagnant between those two. So it's neither increasing nor decreasing. Oops. Okay, so which of the following functions is always increasing? So I know right off the bat it's not this first one, because it starts off by decreasing. It decreases between what looks like x equals -2 and x equals 0. So this is what I'm looking at, by the way. That's decreasing, and so this one is like definitely not it. The second one, even though it curves, it appears to be increasing throughout that whole thing. So from here to here, the y values never stop getting gradually larger. So I would say yes, this one appears to be increasing the whole time. Now this last one is a little tricky because it looks like, yeah, it's increasing from here to here. I'm going to do this in chunks because it looks like it's changing a little bit. So from here to here. And then also from here to here, it's increasing at a slower rate, but it's definitely still, the y values are getting larger, so it's increasing. Now, the only reason why I'm going to say this is not correct is because of this right here. That is neither increasing nor decreasing. So I can't claim that it's increasing just because it's not decreasing. It's stagnant between those 2 points. And thus this is not always increasing. So this is the only one that fits that criteria. Okay, and last, this is not a question, but I wanted to include this slide so that y'all can get more comfortable with distance versus time graphs and kind of what each thing means. This first section right here is uniform speed. So the change in distance over time is speed. And since that's a line, it's straight, it's linear, we know that that's a constant speed. But constant speed is not the same thing as stopping. So the easiest way to think about it is like when you're driving a car. If you're going at a constant speed, you're not stopped, but you are traveling a constant distance over time. But then this right here, this section would be you're actually stopped. This would be like you came to a stop sign and you stopped for however many seconds. And then right here is also a constant speed, but now it's faster than this one over here because it's steeper. So steepness on a distance versus time graph is basically saying you're going faster. Even though it's a constant speed, it's a constant speed that's faster. And now, this is where people get confused. This last little stretch, because this is a distance versus time graph, this does not mean that you are slowing down. This means that you're moving backwards. So in that first section right here, you are moving forward. Then you stop. Then you continue to move forward at a faster pace. But now right here, you're moving backwards. So you turned around, you made a U-turn at this point up here, or something like that. All right,